All right, let's go and start looking at your lab so you'll have an idea when you start looking into queues what I'm doing. This lab hopefully won't be too complicated. But we're going to implement a stack and a queue in whatever data structure you desire. You may choose whatever you want. If you want to implement it with binary tree and hash table, sure, go ahead. I will laugh at you, but go ahead. Remember, you may use code from a previous lab. Hint, hint, wink, wink.
Basically, yes.
Hold on. Wait, just wait for it, okay? Don't say it yet. Let's wait for the right moment.
Aww.
Okay. All right, so the stack, well, we're going to actually implement the stack today. You can create an empty stack, or you can copy the stack over from another stack, and then you need a deconstructor. We want to be able to get its length, returns the integer of its length. Is empty, Boolean if it's empty. Print to just print it out. We can push onto the stack. We can get a reference to the top value. We should be able to pop and also be able to set if the two are equal. For top, I'm never going to ask a top unless I know there's a value inside your stack. So just assume that that's the case.
Thank you.
Not a problem. All right. Okay, so we have that. Let's go inside of SRC. Looks like I've already stubbed a lot of this out for you. Well, let me go back up a level. There we go, gvim src stack.hpp. Go ahead and increment the font size. 12. Yeah. So I've just copied everything over. We'll go ahead and make a new tab for src stack.cpp. Hey, look, I've already stubbed it out. Isn't that great? I wonder if it compiles. Let's find out. No. Undefined reference. I did. I think I put the wrong thing in. Oh. If defined stack.h. There we go. Let's try that. Oh, there, it compiles. Okay. Wow. Well, anyways. Okay. All right. So we have a stack. We want to implement a stack. Everyone take a deep breath. We implement a stack. We can use any code we've already written. All right. Here's the moment. What should we do?
Use arrays.
We could use an array.
Use a linked list.
Use a linked list. What should we do?
Pick the easiest.
Which is?
Arrays.
We could use arrays. What would be easier than arrays?
Pointers.
All right.
Pointers. Yeah.
So what should be, okay, what should be our private data?
Size. So M head.
Okay, we could do that. What would be even easier? What was the big hint?
Shadowcat.
Shadowcat.
What?
So we could use dragons.
Remember, you may use code from a previous lab.
Oh,
So what can we use?
dragons.
Deep breath. What class code have we already written? We already made a linked list.
Yes.
So
Yeah.
Use a linked list.
we should,
Use a linked
Put
list.
a linked list in there.
Copy.
Speaking of code-
Copy pasta.
what are we copying over?
The linked list.
The linked list. Okay, all right, hold on. Let me do that first.
Click that part of that.
All right, hold on. Yes, Craig?
Speaking of code on GitHub, I did not see the code for the linked list.
Okay. It should be up there. I will have to help you later. All right, so we're going to copy that over. Okay. Whoops, why did I do that? We'll go ahead and pound include
Yeah, it is up there. I see that.
list.hpp. Let's go ahead and do a tab new slist, whoops, src slist.hpp. So we have an SL list. So I'm going to go back. So what am I going to put in private? SL list of
T.
T. And M stack. Should it be a pointer or just the regular thing?
Pointer.
You want a pointer? All right, we'll do a pointer.
I don't know. Which is easier.
What is the right answer?
What is the right answer? It depends. All right. Let's see if that compiles. Man, stop. Tabbing. All right. Let's see if we can.
Where are those random numbers coming from?
Let's minimize this thing. It's just driving me nuts. There we go. All right. So we have a stack. All right. So when we call a constructor, what should happen?
It should create the stack.
All right. So m stack equals new.
Singly listed stack. Oh,
Like that. Let's see if that works.
sure.
Hey, it liked it. What should the destructor do?
Delete. And stack.
Okay.
You win.
Let's see if we actually win. Let's do Valgrind.
Oh no.
Hmm.
Yay.
Yeah, it
I
worked.
like seeing that.
Okay. Well, that was nice. How do we get the length? Let's look at the stack. What do we have? Or I'm saying singly linked list.
We'll get that.
Okay. That was nice. Oh, but we need to return it, right?
Yeah.
Okay. How about push? Let's see, what do we have? Append, insert at the end of the list.
Insert at the end of the list. So append.
Do we have somewhere to get at the end of the list?
Remove.
Hmm.
No.
Maybe we should, but think about our data structure. Are we appending to the end, or are we inserting in the beginning with the single linked list? Remember the picture from 30 minutes ago? The singly linked list picture. The linked list picture.
Are we doing it to the end?
Well,
Wait, no, because that's technically the top.
so we were doing it to
Beginning.
the beginning. So how can we insert to the beginning with this code?
Use insert.
All right.
That's the beginning.
I just realized I misspelled some things. So that would be position 0, comma val. All right.
How was that a misspelling?
What did I misspell?
You said you misspelled something.
Oh, yeah, because I had a dot up here instead of an arrow. It's a misspell. Let's make sure it still compiles. Whoops, that's Valgrind. Okay.
You misspelled pedal with them.
All right, so what's top?
And the other one. Oh, the operator.
Okay. So we want to return, you're saying mstack sub 0. All right.
Because it's the top, right?
Yep.
Person.
I don't know if that's actually legal. I didn't think so. So we have to dereference stack first because we made him a pointer. Ooh, sec fault. Ah!
No.
No! No!
Why?
I don't even know why. Let's create some tests.
Whoa.
Let's actually start looking at our code. Empty test. Wow, that's terrible.
Fantastic.
Test 2. We'll do stack push test dot. We'll just do stack test.
That works.
dot cpp. Right, I didn't type it correctly, so let's try that again. Empty stack to test stack test.cpp. Now we'll go in here, tab new. There we go. Test stack test.cpp. There we go. Oh, cool. Test 1. Let's go ahead and create a stack of integers. st. Make it on the stack. Make the stack on the stack. Haha. All right. st.push. We'll push 15, and then we'll do a ts assert that top equals 15, and then we should be able to do st.pop. All right, let's see if we typed any of that correctly. Make empty dash, not empty test, stack dash test. Segmentation fault. All right, let's GDB the test runner. Where's the test runner? Really? GDB test runner.
Get test runner?
GDB.
3073
Yeah, I was like, what are you doing? Starting program, no X. Wait, what? Did I type something wrong? Oh, test dash runner. Now we run it. All right. Seg fault. This stack dash test CPP 12 when we're trying to get the top. Oh, so it doesn't like top.
Why doesn't it like top?
That's a great question. Why doesn't it like top? It's dumb.
Well, we also didn't define what happens in pop.
That's true. Have we called pop yet? No, we haven't gotten to pop.
Oh, yeah. And
That
you
might be
called
important.
pop in the stack test. Does it not like it because it's a pointer and you don't need a pointer? Not there, I just meant like in general because we also have it in the HTTP file.
Well, retrieve the element at the position pose, which should be 0. That should be fine. Shouldn't be giving us any problems. But it's saying that that is causing a seg fault. So let's take a look at it. Oh, did I never define this thing? Oh. Wait, that's stack. Tab new source singly linked list. There we go. There we are. Rover's head. You keep going over rover, and then you return the data. That shouldn't be causing any problems. It's broken. Let's put a little. It's solver 9000. Okay. Those equals. Let's see what we got here. What is it going to print? Yep. See what happens when you overload operators? Make the stack test. Those equals 0. Segmentation fault. That's interesting. What does mhead equal? Mhead's null.
Why?
That's a great question. Why is mhead null?
Did we push to it?
That's a good question. Did we push? We pushed 15, which should have called insert, so maybe our insert function's not correct. Where's insert? I hope it's not a long, complicated function.
There it is.
All right. This doesn't make any sense. Why would it be greater than or equal to? Wouldn't it just be greater than? Because if it's equal to m size, then that means you're adding to the end of the list, right?
Yeah.
Right, so this should be greater than or equal to.
No. I mean, it should.
That's what it should be. Oh, I really didn't like that.
Oh no, it didn't.
Oh, no, it didn't. Woo! That's bad. So it looks like this code's wrong. All those segmentation errors.
Well, because I don't see anywhere in the code that you actually set a value to mhead.
Okay, so here we have rovers to
You set
mhead.
rover to mhead, but you don't set mhead to anything.
That's true. Why don't we ever set mhead to something? So it looks like we need to add that. If mhead equals null, mhead equals node,
Yeah.
node. And we also need to set mtail as well. Okay, I see what you're saying. So we're still getting the seg fault, probably because we need to take care of this. Because rover's at head, which may be null, get the value. Increment rover, it's never going to happen. And then, oh. Right, because then there's a seg fault right here. So right here we're basically saying if rover does not equal null, then you want to do these steps, because that's how you hook up the next, but because this code won't work if rover is null. And then if head is null, then you want to actually set it to the node. Okay.
Oh, no.
Yay!
Happiness occurred.
Whoa!
I'm sorry, sadness occurred because we passed the test.
Yeah, now we passed the passed the test. And that's what happens when you don't test your code. All right, so we push, and we can pop the 15, and let's now push 25, and then top should be what? 25, and then we push 35, the top should be 35, and now if we pop, the top should be 25. Let's see if all those tests work. No, failure. All right, let's see.
That's sort of 0.
Yeah, it doesn't even work.
It doesn't like the 5 to the top.
Nope.
Do we set head to the top value?
Let's check that insert.
Wait, whoa, I have a lot of questions. What's going on?
I was going to say look at the top function.
So the top function here, oops, where are we?
There.
Top, mstack sub 0. So we're going to, well, that should make some sense.
Yeah, no, that's fine.
Yeah, that looks like what we want. We just, our singly linked list isn't fully correct yet. Which, yeah, which is common.
Are you sure? Am I doing this correctly? Corrupt? Do you have pop find yet?
Oh yeah, you still haven't defined pop.
Hey, how about that? You haven't defined pop.
I was
Ah.
about to say, well, oh, here you're trying to
I'm trying to
do
pop.
something that
but
isn't
we
there.
Don't do pop.
All right, so
Do we need to remove?
yeah, we need to
from
remove.
the 0 position?
Dot remove. What are we removing? The value. Oh, it removes all the value.
Ooh.
Never mind.
Well, isn't that easy? What do? Yeah. What do? Don't we just remove? What do we remove?
Stack 0?
Yeah.
The top,
Oh, okay.
right?
Yeah.
Sure.
Let's
But
see.
You still, don't you have to,
Forgot the arrow.
What does the arrow do?
The arrow is a shorthand. So hold on. I'm going to go answer your question right now. Oops. These two are the same commands.
okay. You have to deallocate the pointer.
Dereference.
Dereference, not deallocate.
All right. Then what was our error?
Please leave that code.
What are we doing here? So it poses 0. Head is double free corruption. Oh no!
Double free corrupt.
Yeah, double free corruption. So remove. Looks like our singly linked list implementation was not correct.
Cool.
Awesome.
Fantastic.
Fantastic. Who did this? Who wrote this code?
I wonder. Whoever they
The
were.
dark side.
So rover and delete me, mhead's not equal to null, and mhead.data case where, yeah, head is removed, which is what should happen each time. Delete means the head equals the next, delete the delete me. Yeah. Well, that looks fine. Why is that no worky?
I don't know. Whoa.
Hold on a second, I just realized. Oh, because we're keeping track of m size. And guess what we never decremented here?
M size.
Yeah, we never decremented down here either. Man, this code is terrible.
Forgot about
Who-
the size.
Who does this?
The dark side.
Oh my goodness. Alright, let's go add that real quick. Hey, it aborted this time. That's cool. Assertion failed, double free. So we still got a double free going on. Let's see what the double free is. I love this. We're doing great debugging today.
Woo.
Oh, that doesn't even tell me.
No such file.
Alright, info stack. Let's see what the stack is.
Oh no.
Malloc pointer, int free. It's in the destructor.
Whoa. What did you do?
W-
Is GDB a
The
debugger?
deconstructor.
Yeah, GNU debugger.
Can we use that?
I don't know.
Yes, I taught you that in like the third lecture of this class.
I forgot about that.
All right, what line is this on? Double free corruption on line 32. Yeah, it doesn't like it. That's interesting. Because we have prev equal to null, rover's ahead, while rover's not equal to null, keep going. Prev does not equal null, delete it, otherwise prev is the new rover. And then you keep deleting behind, and then eventually you'll get to tail. You know, technically, yeah, I don't know. Technically, prev should be here, because you're always deleting the previous. But I don't think that's going to fix this error. Or maybe it will. Okay.
Why were you saying, oh, MTL doesn't equal null, delete it, and then make it equal to null?
Yeah, make it equal to null down here.
Yeah.
And its size is 0. Yeah. What's going on here? Anyways, what are we doing? So we got all sorts of funny things happening. So let's take this one by one.
I love it when that happens.
Oh yeah, me too. So we're pushing 15. We're going to get the top. Let's see if that passes. It passes.
Yay!
All right, so we're going to say that that's our first test. So we'll just copy pasta. There we go. Test 2. Let's go ahead and add popping, pushing, and then getting 25 back. Let's see what that does.
Oh, it passed.
That passes as well. So that's not the problem. Let's go and copy pasta this again.
What? Yeah.
What?
I don't understand.
I'm just creating different test functions.
No, we
No, I
don't
understand that. I don't understand why it's not working.
Oh, yes. Okay, good. I was like, this is all I'm doing, guys. All right, so let's see if we push 35. Does that cause sadness? There we go.
Why does it cause sadness?
All right.
We already did it twice successfully.
So,
like 35.
well, that's what happens when we push twice, right? So we need to figure out what's happening when you push twice. So one thing that might be helpful, we have append and we have print. Maybe we should implement the print function in the stack so we can help debugging. How do we print inside of this thing?
You look through it.
You're thinking too hard.
I already knew that.
I've stacked up.
And stack.print. Awesome.
What? Oh.
Because then you're just calling the print function of the singly linked list.
We have it already.
We already wrote the function. Let's not reinvent the wheel. Trying to drive this home. All right, so now what we should do for this test, by the way, we probably should get rid of these other printfs that are in here, and by that I mean couts, like those two. Let's recompile real quick and run. It fails. Great. Well, you know what I mean. So let's go ahead and push 25 and do st.print, and then we're going to push the 35 and call print, and let's see what happens. So first one's 25, and then it becomes 25-35. So it's not actually pushing the 35 to the front, it's pushing the 35 to the end. So we messed up somehow. So that's the problem. Let's go look at what we're doing. Insert at 0, which should be the front. Unless we really wanted -1. I always like testing that first, just for funsies. Seg fault, that's what I thought. So we do want to insert it at 0.
But what's the insert?
Let's go back up to 0.
You mean insert?
That's what I said, right? Insert.
Sure.
0.
That's totally what I said.
Okay.
All right. So if pose is 0, rover is head, you have the new node. Rover's not equal to null, you put the new node over.
What is the head set to? What? You have rover equal to mhead.
And yeah, mhead in this case has the first node. node. We create a new node, sets value, and it's data. Let's go ahead and draw this on the board. Well, I can see this in my head. Y'all probably cannot.
I can't see inside your brain, so that is a correct statement.
Y'all got it? Yeah, the other thing I get used to is reading code and figuring out what it does.
Always get the rubber duck.
The rubber duck. Yeah, doesn't quack like a duck, talk like a duck. You have the wrong level of. All right, so first thing we do,
Way to say that.
It's not that.
so we'll have m head, and in this situation, it's pointing to 25, 0. That's what we have. We also have m tail pointing to this guy, and we want to push 35. That's what's causing the error. Did y'all see that from the code?
Yes.
Okay, great. So what does this first do? So we have rover pointing to m head, so rover's going to point there. Great. And we're going to create a node with the value 35 and going to null. I just realized all the people online cannot see the screen.
Nice.
M head and tail pointing to the 25. We have rover point to the head, aka 25. Create a new node of 35 because we're trying to push 35. All right, great. For int I up to pose, rover equals rover.next. Well, we're pushing pose in this case is 0 because we always insert at 0, 25. I don't know why I wrote it like that. That's actually an arrow.
Why?
That is an arrow.
Why is it insert 0, 25 if we're pushing 35?
I think that's actually a 3. Will you please look again?
Now it's
It's in
in
the
the
glare.
It's in the glare zone.
Oh, it's in the glare. Oh, yeah.
It's in the twilight zone.
Insert 0, 35.
You almost did it again.
There we go.
Still looks like a smiley face.
That's an arrow.
Creepy smiley face, dude.
All right, insert 0.
It's a smiley face.
So nothing's going to happen with rover. If rover does not equal null, which is the case, rover dash m next equals rover. I'm sorry, node dash m next equals rover dash next. So we are what?
Nothing.
So we're hooking this up. That's that line of code. Then rover dash m next equals the node. Oh wait, this isn't good. So then this goes down to here. That ain't right.
Yeah. No,
That's not right.
Oh no.
That's a circular linked list.
Oh yeah, we messed this up.
You missed this.
Oh.
Wow.
No,
Most of
that
them.
was you. That was definitely you.
Extra credit or will tell. There's no mercy in data structures.
There is no mercy. All right, so what was the error? The error really is this step, this arrow right here. Because in our situation, we want him to still point to null. So let's go ahead and jump back. Right here, so rover equals node. That's assuming we want the node to come next, which is not the case. Really what we...
M previous.
No.
We don't have an M previous.
No, you want...
In order to be equal.
You don't want... I don't even know why we're doing that.
Wait, what did we want? What are we doing? No.
Because rover is the next element, but there's no previous. We don't have a...
need an M previous.
We do need an M
We need
previous.
a doubly linked list.
No, we don't. We just need a previous. So node
Isn't it technically
prev equals null.
No, it's just the one. The rest
All
of
right.
them
And so in here, we'll go ahead and have the code be prev equals rover. That way prev will always equal to what's previous a rover. So let's go back to this example. Now we're going to have prev. He starts at null.
That's the
Excuse me. And he's going to stay there. He's not going to move. because we never increment rover. Okay? Okay?
Sure.
Yeah. So if rover doesn't equal no, no dash next is to rover. That's what we want because that's this arrow right over here. And now we want if prev does not equal null, that means there is a previous. We want prev dash m next to equal the node. Right now that's not happening here because we don't have a prev. So since prev is null, we don't hook up some element to this node. All right, now here's the tricky part. If n head is null, we set that there. Really, hold on a second. Really the issue is if m head is null, you want to settle those. Oh, there's too many corner cases. Oh, there's so many corner cases. So if prev equals null, which is actually just the else of this guy, m head is equal to node, right?
No.
And then we also need the last check that if m tail is equal to null, then m tail will equal to that new node because then we need to update the tail. Oh, the chances of this code being correct is so low. And then
Isn't that the case always?
it is the case. And then also, lastly, if m tail does not equal null and m tail, does not equal null, that's actually not what I want to test. The other test case we need to have is in the case where we insert at the end of the list, and that would happen. How would that happen? If rover dash next is null. So if rover dash m next equals null, then m tail equals rover. All right, chances of that being correct, probably not that great. Let's see what happens. That's what I thought. GDB test runner. We're gonna have to do this better next time. 104.
That thing you just wrote.
Rover does not equal null, and rover dash next equals null. Then you update it that way. We forgot to do our standard null check. Oh,
It worked.
it worked.
Whoa,
Kind of. What happened to the 25?
Oh no.
Oh no.
that doesn't exist anymore.
All right. Let's
Did we pop it?
um.
I don't remember what we
We
did.
pushed the 35, and then I printed. I didn't pop anything.
Did you override?
Yeah. So let's see what happened. Let's go back to the code. Let's see where we are. We have rover going to head. Prev is null. Node's 35. We're trying to insert 0. So we have head. Prev is null. New node. We don't increment rover. If rover does not equal null, which is the case, node dash next equals rover dash next. So node dash next equals rover dash next. Great. If prev does not equal null, which is not the case, so we ignore that. Prev is null, so then head is going to equal that node. All right, so we do this. Okay. Then, if m tail equals node, which is not the case, m tail would equal node. If rover does not equal null, which is the case because rover's pointing up here, and rover dash next equals node, then m tail equals rover. All right, so it's over there. That seems like a superfluous check. Huh. I don't think it's rover we're looking at, it's actually node. Because if node does not equal null, which is a silly test, if node dash m next equals node, then m tail equals node. That makes more sense because you only want to put tail back there when it's actually at the end. All right, but we're still not printing the thing out. That's interesting. Let's look at the print statement. Print. Huh. Wonder why it's not doing it. Let's go ahead and, wow. That's not what I wanted. Let's try that again. Let's go ahead and put in a parentheses, followed by rover-m next to see what's actually the next pointer is. And then we'll put in a closed parentheses. That way it'll actually print out the pointers for us. So the next is 0, next is 0. So it's making 35 next equal to null, which implies that where are we here? Insert, which implies that node-next is not being up. Oh, node-next not equal to rover-next. It's just equal to rover. Aha. Because rover-next would have been taking this guy and moving him to here, which is not what we wanted. We wanted to go up. So we drew it correctly and typed it wrong.
I knew that.
Totally.
Did that the whole time.
Errors will get you every time.
There we go. That's what we wanted. So 35 points to this memory address,
That is a very
and then 25 points to 0. Great. Okay.
interesting address.
Let's see if we can pop. Okay, we can pop as well. All right. Well, that was fun, cleaning up our singly linked list. What else is left? Is empty.
Is that
What's the length of it? If the length is 0, return false.
So we're going to return mstack.length equals 0. Right?
Yep.
All right, let's go ahead and write a test for that.
Another test.
Should write tests for all these things.
Tests are fun
Oh, they are great. All right.
if your code actually works.
All right, so ts assert. I'm sorry. st.is empty because it should be empty. And then once you push something, it should no longer be empty. And after you pop it, it should be back to being empty. But then after you push something, it's not empty, and after you push something, it's not empty, and after that last pop, it's not going to be empty either because there's still something on it. Let's do it. Woohoo! All right, how about all those tests? That was easy. All right, what's the last thing we have to do?
Delete it.
Oh, we already deleted it. My cursor's on it.
Is that the constructor?
Mm-hmm. Copy constructor.
Oh.
Do we have to copy it?
Yep. Uh-oh.
Spaghettios.
Wait a minute. Do we already have that, though?
Didn't we?
We do! mstack equals new SL list sub t, passing in. Not quite. Almost there.
Dot.
M stack. All right. Okay, I'm going to stop there.